when we have D2sp3, and the other possibility is sp3d2. Now, this D2sp3, it is known as inner orbital complex. Why? Because we have seen that in the D2sp3, what are we using? We are using 3d, 4s, and 4p. That means the d subshell which is being used is n minus 1. Outermost से एक कम. So please write here inner n minus 1d orbital is used in hybridization. Next, this is known as inner orbital complex. Also, in these cases, electrons are generally paired. Generally paired मिलेंगे. We also call it low spin complex because इसमें pairing की भी रहती है. Generally यहाँ पे आपके पास electrons क्या रहते हैं? Paired रहते हैं. That is why these are known as low spin complex. Last point. Now this is also known as spin paired complex. Spin paired complex. Another hybridization that we have is known as sp3d2. In this hybridization, we use outer, that is nd. है ना? nd orbital. N is the outermost shell. nd orbital is used in hybridization. In hybridization. This is known as outer orbital complex. Outer orbital complex. Next, in this cases, electrons are usually or generally unpaired. Electrons are generally unpaired. Next, we have high spin complex. In high spin complex because here the unpaired electrons are present, so that is why the spin magnetic moment, we'll talk about that, that is going to be always greater, and this is known as spin free complex. So NCERT, I mean CBSE board examination has never used this word till now, spin paired and spin free. Although it is mentioned in NCERT, spin paired and spin free complexes. ठीक है, तो इसको ध्यान रखिएगा जरा. Raise your hand once you're done. Then we are going to look at more examples. Let's done. ठीक. Next. Questions इस तरह से कुछ आते हैं. Please write with me. FeH2O whole 6, 2 positive, is paramagnetic. is paramagnetic, but FeCN, whole 6 core negative is diamagnetic. Is diamagnetic. Explain. So we are writing this according to the valence bond theory, but after studying the crystal field theory, we are going to use certain words which are going to be replaced in the answers. हम सारी चीजें फिर बाद में बता देंगे, ठीक है? But how are we going to answer this? For example, we have FeH2 whole 6, and here we have two positive charges. Then here we have FeCN whole 6. Here we have four negative charge. Now, if I talk about the oxidation number, then Fe is going to have X plus water. Obviously, it is neutral. So 6 water molecules having zero charge, it is equal to +2. X will be equal to +2. Next case, we are going to take the oxidation state of Fe as X plus we have 6 cyanide. Cyanide is a negative ligand, that is an anionic ligand which is having a charge of -1, which is equal to -4. So X will be equal to 6 minus 4, that is equal to 2. Okay? So in both the cases, the iron, it is having oxidation state what 2 positive. So we can write the Fe2 positive will have electronic configuration argon 4s will be 0, 2 electrons are going to be removed, and Cd will be having 6 electrons. Now, obviously, in FeH26, which is paramagnetic, in that case, there will be no pairing. In this case, what will be happening? No pairing. There will be no pairing in this case. Now, in the case of FeCN6, obviously there will be pairing taking place because it is diamagnetic. Diamagnetic का मतलब क्या होता है? All the electrons are what? Paired. Diamagnetic. That is why it is what we'll write pairing. Fine. Now, when there is no pairing happening, 1, 2, 3, 4, and 5. We have the 5d orbitals and we have 6 electrons. So 1, 2, 3, 4, 5, and 6. Now, in the case of pairing, 2, 3, 4, and 5. Now, in this case, 1, 2, 3, 4, 5, 6. This type of pairing is going to occur. Obviously, this is 3D. 3D में तो कोई space है नहीं. Obviously, what are we going to use? In both the cases, the coordination number it is equal to what? 6. So we need 6 vacant orbitals. So we are going to use after 3D there is 4s. After 4s there will be 4p, and after that 4d. After that 4d. Now from S I will be using only one orbital because S has only one orbital. P has 3. So I will be using all the p, and we have 3 plus 1. 4 orbitals are done. We need 6. So from the D I will be using D2. Now in this case we already have the 3D orbitals. From 3D I am going to use 2. Then I am going to use the 4s, and then I am going to use the 4p. In total we need 6 because the coordination number is 6. So for 3D I will be using 2 orbitals, S के लिए 1 orbital, and P के लिए we are going to use 3 orbitals. So this is going to be D2 sp3, and we can say that this is sp3d2. So obviously it is going to be outer orbital complex. It will be inner orbital complex. Then here it will be high spin. Here it will be low spin because it is completely spin paired. Both of them are going to be obviously octahedral in shape. ठीक है, please write this down. Raise your hand once you're done. Similarly, we are going to compare NiCl4 and NiCN4. ठीक है? Another one is NiCl4, 2 negative, and we are going to compare NiCN4, is also 2 negative. Fine. इन दोनों कॉम्प्लेक्स फॉर्मूला को देखना है. अच्छा, obviously there are some information of this given here. For example, NiCl4, it is given that this paramagnetic, this is diamagnetic, है ना? इसको explain करने के लिए, in both the complexes you can see that nickel is going to have +2 oxidation state, है ना? Cl के लिए -1, Cn के लिए भी -1, 4 -2, it will be +2. In this also it is +2. Here it is also +2. In both the cases, nickel will be having a +2 oxidation state, and the atomic electronic configuration is going to be argon. 4s will have 0 electrons because the 2 electrons from 4s has been removed, and 3d is remaining with the 8 electrons, 3d8. Now, the configuration that we are going to have is again going to be two different configurations because of the paramagnetic and diamagnetic nature, and we can write it like this. Now, in this case, we are going to have 1, 2, 3, 4, and 5. These are the d orbitals, and similarly, we'll be having the 5 d orbitals here also. Okay. So paramagnetic, obviously, that means there is no pairing. No pairing. And here you will be having some pairing. यहाँ पे pairing होगी. क्या देखिए जरा, we are having 3d8, so it will be 1, 2, 3, 4, 5, 6, 7, 8. अच्छा, no pairing का मतलब ये नहीं होता that there will be zero pairing. Pairing will occur only when needed because we have to fill 8 electrons where the other electrons are going to go. They are going to go somewhere, right? So obviously pairing is going to happen for that. We are not doing the pairing by leaving the orbitals vacant as we were doing initially. है ना? Pairing का मतलब क्या हुआ? You leave the orbitals vacant. Starting से ही क्या करना? Pairing करना. For example, in this case 3d8, when we are going to do pairing, we will be do like this: 1, 2, 3, 4, 5, 6, 7, 8. In this case, we have left an orbital vacant and still paired. Here we are not doing that. Here we are just following the Hund's rule of maximum multiplicity. In this case, the 3D is completely filled. By the way, what is the coordination number for both of them? Can you guys tell me? For chlorine and the CN? What is the coordination number for both the complexes? 4. For both the complexes, it is 4. Right. And we need how many orbitals? We need 4 orbitals. So obviously, we don't have any of the 3D orbitals remaining here. So I will go to 4s. And then we have one orbital from the 4s. We will be having all the 3 orbitals from the 4p. The hybridization will become sp3. In this case, we are having one orbital from the d. So we'll take that d. And then, by the way, which d? 3d. This is 3d. So 3d, we are going to take one orbital. Then we are going to go to 4s. In 4s, I will take one orbital. We need 2 more. So I will go to 4p. So from d, I will take 1 because there is only 1 remaining. From s, I will take 1 because it has only 1. From p, we have 3, but we are only needing 2. That is why I will take dsp2. Now, this sp3, it is going to give you tetrahedral complex. And dsp2, it is going to give you square planar complex. Square planar complex. Please copy this down. Raise your hand once you're done. The only thing that is going to get changed once we do the crystal field theory is this part, whether it is paramagnetic, diamagnetic, or part. Copy this down, raise your hand once you're done. By the way, मतलब इतना करके मत छोड़िएगा, इसके आगे की चीज हम नहीं कर रहे हैं ना, जो लास्ट क्लास में कराया था. You have to do this whole thing. Explain according to VBT if they ask ना, तो ये पूरा कीजिएगा. ठीक है? I have seen the marking. Sorry, I've seen some toppers booklets, answer sheets. CBSE generally it releases and the answer sheets of toppers once the examinations are done and everything. So I've seen those people, they do it like this always. ठीक है? तो वहीं से हमने भी यहाँ पे लिखा, right? We have to do it completely like this. आप यहाँ पे D2SP3 जैसे 6 बनाया ना, वैसे यहाँ पे भी आप sp3 के लिए you are going to make 4 orbitals and then do the count, but we are going to do this again once we do crystal field theory. ठीक है, everyone is done. बस एक चीज आप लोगों को रिवाइज करा देते हैं, that is magnetic moment. इसका पूरा नाम होता है स्पिन मैग्नेटिक मोमेंट. स्पिन मैग्नेटिक मोमेंट क्या होता है? म्यू इट इज इक्वल टू अंडर रूट n into n plus 2 bm. bm is Bohr magneton, that is the unit. ठीक है. What is n? Equal to number of unpaired electrons. Number of unpaired electrons. ठीक है. इसको हम लोग यूज करेंगे, बस इस फॉर्मूले को अभी लिख लीजिए n into n plus 2. This is going to be used after that. After this, इसके बाद ना ये ही लिख लीजिएगा टॉपिक. Then raise your hand. Crystal field theory. Raise your hand once you have done writing till crystal field theory. क्रिस्टल फील्ड थ्योरी की जो कहानी स्टार्ट होती है वो स्टार्ट होती है 5 दोस्तों. कुछ लिखना नहीं है आपको अभी, तो ध्यान से सुनो. आपके पास 5 दोस्त हैं. ऑल ऑफ देम आर इन देयर लंच पीरियड. लंच पीरियड में ये आराम से क्या कर रहे हैं? बातें कर रहे हैं. जस्ट हैविंग अ गुड chat with each other. And all the 5 friends are having good chat with each other. Now, what they see is they're chatting, they're pretty chill. Okay, everything is fine till here. Everything is fine till here. They don't have to worry about anything. But very soon they see that their sports teacher or principal, जिससे भी आपको ज्यादा डर लगता हो, ठीक है, they are watching. तो क्या कर रहे हैं? इन पे नजर रखे हुए. The principal is watching them, or the PT teacher is watching them, है ना? Sports teacher is watching them. Just let me give them some suitcase, ना? थोड़ा लगेगा हाँ प्रिंसिपल है. तो सूटकेस कौन ही यूज करता है आजकल? तो व्हाट दे आर सीइंग, दे वर हैविंग लंच, दे वर टॉकिंग विद ईच अदर, है ना? प्रीटी चिल, कुछ इनको टेंशन नहीं. अचानक से क्या देखते हैं? द टीचर इज व्हाट इज लुकिंग एट देम. व्हाट्स गोइंग टू हैपन? इन सभी का ऑल ऑफ देयर हार्ट बीट विल स्टार्ट टू इंक्रीज. सभी के दिलों की धड़कन क्या हो जाएगी? तेज जाएगी. सेंस आया ना? बताएं. If the principal is constantly watching you, what will happen? All your heartbeat will start to increase. Yes or no?
Yes, sir.
है ना? All of them, they are going to have fear will start to creep on. है ना? Fear will start to creep in. है ना? And what happens? Then the principal is also approaching them. The principal is also approaching them slowly and slowly. As the principal is approaching, their heartbeat will increase even more. Their heartbeat will increase even more. As the principal is approaching, the heartbeat will increase even more. And then what happens? The principal reaches here. It says, let's suppose, Mariam and Harsha, please come with. Mariam और हर्षा को लेकर चलेंगे. ठीक है. By the tone also. अब क्या होगा? मरियम और हर्षा की दिलों की धड़कन और ज्यादा तेज. They will be like, oh my god, अब क्या होने वाला है? Right? Their heartbeat will increase even more. What will happen to the others? उनकी हार्ट बीट अब नॉर्मल हो जाएगी, नॉर्मल क्या उससे भी कम हो जाएगी, तो क्या सोचने लगेंगे, अरे अभी हर्ष और मरियम आएंगे, कुछ तो हुआ रहेगा उनके साथ, हम लोग मजा लेंगे, उनको ये करेंगे, ठीक है। इनकी हार्ट बीट क्या हो जाएगी, और भी, इनकी हार्ट बीट और भी कम, इनकी और भी। कुछ ऐसा ही होता है हमारे लिगेंड्स के साथ, ठीक है, कुछ ऐसा ही होता है हमारे किसके साथ, लिगेंड्स के साथ ही। व्हाट हैपेंस इज, ध्यान दीजिएगा जरा, डोंट हैव टू राइट नाउ, वी हैव 5 d ऑर्बिटल्स, ठीक है। जैसे ही लिगेंड अप्रोच करता है, इन सबकी एनर्जी क्या कर जाती है, इंक्रीज कर जाती है। ऑल द एनर्जीज, all the d orbitals, they experience an increase in energy when the ligands approach. By the way, why there is an increase? Because ligands are negatively charged, d orbitals are going to have electrons, इलेक्ट्रॉनिक रिपल्शन की वजह से एनर्जी इंक्रीज कर जाती है। बट आफ्टर दैट दे सी दैट लिगेंड्स आर नॉट अप्रोचिंग ऑल ऑफ देम, वो कुछ ही को अप्रोच कर रहे हैं, तो फिर स्प्लिट कर जाती है। द टू ऑर्बिटल्स एट विच द लिगेंड्स आर अप्रोचिंग, उनकी एनर्जी और हाई, बाकी तीन की कम हो जाती है। दिस इज नोन एज स्प्लिटिंग ऑफ डी ऑर्बिटल। इन सब चीजों के बारे में हम लोग लिखेंगे, एक आइडिया आपको लग गया, यहाँ पे लिखिएगा जरा, start writing from here a few points. CFT considers metal ligand bond to be ionic, to be ionic, arising from electrostatic interaction, arising from electrostatic interaction between metal and ligand. अब आयनिक मान रहे हैं, तो जो एनायनिक लिगेंड्स है, एनायनिक लिगेंड्स आर कंसिडर्ड, anionic ligands are considered point charges and neutral ligands are considered dipoles, are considered dipoles. Next point, as the ligand approaches metal, as the ligand approaches metal, the 5d orbitals, the 5d orbitals experience repulsion and their energy increases. And their energy increases. Next point. The orbitals line the orbitals line in the direction of ligands experience greater repulsion, and their energy further increases, है ना। वैसे जैसे हर्षा और मरियम को लेके गए, तो उनकी एनर्जी क्या होगी, और ज्यादा बढ़ गई। The orbitals lying orbitals lying away from the direction of ligands experience lower repulsion and their energy decreases. and their energy decreases. Some of the d orbitals they have increased energy, some of the d orbitals may decrease energy. That is why this causes splitting of d orbitals. This causes splitting of d orbitals. सारी कहानी हमने लिख दी है, इसको आराम से लिखते रहिए आप लोग, ठीक है. What happens, each and every point has been written. Raise your hand once you're done. Waiting for Mariam. Next, taking a heading. Splitting of d orbitals. Splitting of d orbitals. Right. The conversion of 5 degenerate d orbitals of central metal atom of central metal atom into different sets of orbitals, having different energies in the presence of electrical field of ligand. चार्ज है तो इलेक्ट्रिकल फील्ड हो गया ना, उसी इलेक्ट्रिकल फील्ड ऑफ ligand is called splitting of d orbitals. Is called splitting of d orbitals. Now, once the d orbitals are split now, this with different energies, higher energy, lower energy, this difference in their energy, it is known as crystal field stabilization energy. ठीक है, या फिर क्रिस्टल फील्ड स्प्लिटिंग एनर्जी, दोनों ही बोला जाता है। इस पर लिखिएगा द डिफरेंस इन एनर्जीज ऑफ द टू सेट्स ऑफ d orbitals is called crystal field stabilization या splitting energy। शॉर्ट फॉर्म में इसको CFSE कहा जाता है। सबने लिख लिया? ऑल क्लियर, डन। अच्छा, now just we are going to revise a bit of the d orbitals and then we are going to look at the crystal field splitting in octahedral. That means when we are going to have six ligands, six, so please write types of d orbitals. Types of d orbitals. Now, there are two types of d orbitals. There are two types of d orbitals. One is known as axial, the other one is known as, बोलो याद है किसी को? एक होता है axial और दूसरा, सब भूल गए, बोलो भाई। क्लास 11th में पढ़ाया था ना हम लोगों ने। एक होता है axial d orbital और दूसरा व्हाट हैपेंड मरियम अन्ना हर्षा, दूसरा ओ माय गॉड नॉन एक्सियल d orbital। In the axial d orbital, lobes or the electron density, lobes are on the axis। इसमें these are two, कितने होते हैं? दो। And in the non axial one, the lobes are between the axis, between the axis of fluid ax es। These are three। These are three। याद है किसी को कि नहीं याद है? हर्षा, मरियम, अन्ना, any one of you remembers what are the axial, non axial? किसी को नहीं याद?
No, sir.
नो, ओ माय गॉड, ऐसे होते हैं ना डी ऑर्बिटल्स, करेक्ट। Axial d orbitals, नहीं sorry, non axial d orbital lobes are between the axis, this is x axis, this is y axis, है ना? And this is known as what? dxy।
Yes, sir. I remember now.
You remember now? Who remembers? Mariam?
Yeah.
What about Anna and Harsha? आप लोगों को नहीं याद आया अभी तक?
Yes,
And
sir.
if the orbitals, you remember it now? If the orbitals are between y axis and z axis, let us suppose this will be known as d, y, z, and if the axes are between x and z. हर्षा आपको नहीं याद आया? हाँ हर्षा, याद आया आपको भी? अच्छा, तो भी डी एक्स जेड। सिमिलरली हमारे पास क्या होते हैं? देर आर टू देर आर टू एक्सियल वन। This is the x-axis, this is the y-axis, and this orbital, it is, in this case, the lobes are on the x and y-axis, है ना? तो इसका नाम होता है dx square dash y square या dx square minus y square. Then we have one more that is known as dz square. In the dz square, there will be a lobe on the z-axis. Okay, this is the z-axis on which there is a lobe present, and there will be a ring type of thing which is on the xy plane. This is a ring on the xy plane. This orbital is known as dz square. Raise your hand once you're done writing. आज लगता है यहीं पे खत्म करना ज्यादा सही रहेगा. Because if I start with the octahedral splitting ना, चलिए octahedral splitting पे करा देते हैं, उसके बाद फिर tetrahedral बाद में करेंगे. चलिए सबका हो गया, ठीक है. तो डिऑर्बिटल्स हमने किस लिए पढ़ा है? ताकि we know that which axis orbitals are on the axis and which orbitals are not on the axis, है ना? उसी के हिसाब से हमारे पास splitting होगी. ध्यान दीजिए जरा. Right, next A part of the splitting is octahedral splitting. Octahedral splitting, उसमें क्या क्या चीजें हैं? फर्स्ट ऑफ ऑल, 6 ligands approach. Six ligands approach the central metal atom, the central metal atom via axis. Through the axis, they approach the central metal atom. What happens? This leads to an increase in energy of d orbitals. Which d orbitals? But energy of, बताइए, अगर एक्सिस से आ रहा है तो कौन से डी ऑर्बिटल की एनर्जी ज्यादा इंक्रीज करेगी? बताइए.
नॉन एक्सियल
एक्सियल वाले की ना, बिकॉज एक्सियल वाले की ऑर्बिटल्स के जो लोब्स हैं वो एक्सिस पे हैं, एंड दीज आर दी ऑर्बिटल्स व्हिच विल बी हैविंग इलेक्ट्रॉन. लिगेंड्स के पास भी इलेक्ट्रॉन, तो रिपल्शन कहाँ पे होगा? एक्सियल वालों के साथ ज्यादा रिपल्शन होगा, बिकॉज see the axial ones they contain electron, ligands also have electron. So if the ligand is approaching, I think we have written this point, huh? the orbitals lying in the direction of ligands. The orbitals lying with respect in the direction of ligands experience greater repulsion and their energy further increases. The orbitals lying away from the direction of ligands experience lower repulsion and their energy decreases. So this leads to an increase in energy of axial d orbitals. Make sense, Harsha?
Yes, sir.
Which are the axial d orbitals? The dx square minus y square, and the other one is, it is known as dz square. And this whole thing, this both of them, they are known as EG orbitals. EG orbitals, an EG set of orbitals, and the energy of non-axial d orbitals decreases. What are the non-axial ones? They are dxy, dyz, and dxz. The three of them, they are known as T2G orbitals. They are known as T2G orbitals. Raise your hand once you're done. Harsha, just waiting for you. अब यहाँ पे थोड़ा आराम से देख लीजिएगा. We are going to make a diagram. देखिए 1 2 3 4 5. These are the 5d orbitals. They are right now in the ground state. इनके पास अभी कोई नहीं आया है ना, अकेले हैं बिल्कुल. They are all alone. They are chilling in the lunch period. है ना, lunch period है, ये आराम से क्या करे, बातें चीती कर रहे हैं. ठीक है, मेटल के पास कोई नहीं है अभी. This is the situation of metal. Now, as soon as metal it is being approached by, when the metal it starts getting approached by ligands, अभी ligand बहुत दूर है. ठीक है. Now this is the spherical field कहा जाता है इसको. In this case, the ligands are approaching the metal, but all of them are there pretty much far away. बहुत ज़्यादा दूर है. So what will happen? All the 5d orbitals, they are going to experience a repulsion which will be similar. Similar repulsion experience करते हैं सारे के सारे. सबकी एनर्जी क्या हो गई थी? कम थी, ज़्यादा. They experience an increase in energy. Now after that, the metal, what they see, when the ligands they actually approach, they are approaching through octahedral geometry. That means there are 6 ligands. 6 ligands के लिए जो सबसे symmetrical approach होगा, that will be, we have 3 axes x, y and z. If I take the positives and negatives, तो 6 जो आपके पास axes बनेंगे ना, positive negative लेके, that will be the most symmetrical way to approach the metal. Obviously nature के अंदर symmetry ज़्यादा होती है. That is what is going to happen. They are going to approach through the axis. And when they are going to approach through the axis, then this orbital, there will be splitting happening. What will happen? How the orbital will split? The two orbitals which are the axial orbitals, they will experience an increase in energy. They experience an increase in energy. And the remaining non-axial one, they experience a decrease in energy. They experience a decrease in energy. Right. So just give me a second. This is an increase in energy. Again, there is an increase in energy like this for the axial d orbitals, and also there is a decrease in energy for the non-axial ones. Okay, for the non-axial ones. What are these two orbitals? These two orbitals are the dx square minus y square, and this one is dz square. Together, this set of orbitals, these are known as the EG set, and here we are having dxy, dyz, and dxz. And these three orbitals together, they are known as T2G orbitals. They are known as T2G orbitals. Now, the energy level which was initially, अच्छा इसमें हम और भी चीजें कुछ चीज देते हैं. For example, this particular part, this is d orbital in free state when there are no ligands, है ना? This is the average energy of d orbitals in spherical field. Right? And this is the d orbitals in octahedral field. D orbitals in octahedral field. अब यहाँ पे जो आपके पास लेवल है, ठीक है, the average energy जो होता है ना in the spherical field, this is known as barycenter. This is known as barycenter. Now, EG level, the EG orbitals, they are above the barycenter. They are above the barycenter. कितना ऊपर है? P/5 del O. अच्छा, what is del O by the way? Del O जो है आपके पास, that is the difference in energy of EG and T2G levels. EG सेट और T2G सेट के बीच का जो डिफरेंस है ना टोटल, दिस इज नोन एज del O. del का मतलब हो गया डिफरेंस. O का क्या मतलब हो गया? O का मतलब हो गया बिकॉज ऑफ ऑक्टाहेड्रल स्प्लिटिंग. एंड द EG लेवल्स आर P/5 del O above. और वहीं पे जो आपके पास T2G लेवल्स है, this T2G level, it is below the del O, sorry, below the barycenter. And how much below? 2/5 del O below the barycenter. ठीक है, चलिए इसको पूरे को बना लीजिए.
Sir, can you explain what is del O again?
del का मतलब हो गया डिफरेंस इन एनर्जी. O का मतलब हो गया बिकॉज ऑफ ऑक्टाहेड्रल स्प्लिटिंग, वही del O.
Okay, sir.
ठीक है. बाय द वे देखिए, एक कंसेप्चुअल सवाल है जो कि जनरली पूछा जा सकता है, दैट ये बात तो समझ में आती है दैट if the ligands are approaching on the axis, the axial d orbitals are going to experience more repulsion. That is why their energy will further increase. The question can come, why do we see a decrease in energy for the non-axial one? Why do we see a decrease in energy? What does it mean by lower repulsion? Okay. So the answer for this question is that energy, it cannot be created nor it can be destroyed. So whatever the increase in energy, the average increase in energy was there initially when the ligands were approaching spherical in a symmetrical, spherically symmetrical field. At that time, there was an increase in energy. Right? Now, whatever happens after that will correspond to that average energy always. And that is why if you see, if I add the energies of Eg and P2G, it will again come to the barycenter, right? Because we have two orbitals in the Eg level, that is why it is, it is 3 times above, but we have 3 orbitals in the T2G level, that is why it is 2 times. But if I am going to combine all of these orbitals, the average energy will be still at the barycenter. If I take the average energy, then it is still at what? It is still at barycenter, because of the reason we have 2 orbitals. ये conceptual सवाल है, मतलब generally तो पूछा नहीं जाता. Like once you do BSc, MSc, and after that, if you go to interviews, for interviews they ask this question. If, for example, if I do, we have how many orbitals in the EG? We have 2 orbitals in the EG. Both of them are 3/5 del O above. Okay. Plus, this is above, and then we talk about the T2G levels. So we have 3 T2G orbitals which are below. Below के लिए क्या sign use करेंगे? Minus 2/5 del O. If you add both of these things, then you can see that this particular thing is also what? 6/5. This particular thing is also what? Minus 6/5. Approximately is going to give you 0. That is the barycenter once again. Fine. So average energy is going to be constant because energy can neither be created nor be destroyed, and hence the T2G levels there should be a decrease in the energy of T2G levels. Why? Because there is an increase in the energy of EG levels. To conserve energy, we have to decrease the energy of T2G levels. That is the explanation why